Good morning and welcome to DETNet. Funny thing is, I just happened to pull out the agenda and pulled out the one that said DETNet Agenda Prague, Congress Hall 1, and I realized it was the wrong day. So we were in this room 2 years ago, so welcome back. I'm Lou Berger, this is Janos Farkas. Ethan Grossman, our secretary, is sitting up front. Our agenda and slides are available in the standard place, as is our working group information. This is the IETF, if you didn't notice. Anything you say and do here is governed by our contribution, BCP 79. If you're unfamiliar with it, please go look it up. We also have the link on the bottom to the note well, which is capturing what you see here. Anything that you say here in the session, at the mic, while standing, become a part of our permanent record and is subject to the IETF contribution rules. We are streaming video and audio. The video will be posted also after the session. So if you do come and speak, please make sure to mention who you are at the mic. You don't need to say company affiliation, but you do need to say your name. Please also help out by joining in on Etherpad and help with our collaborative note-taking. It's particularly important if you make comments at the mic to go check to make sure that your name is there properly and that your comment is appropriately captured. So please jump on. You actually don't need to put the question mark part there. If you just put in notes, IETF104-DETNET, that'll get you to the right place. There's also a link to it on the tools page. It's a little easier to find. This is the agenda that was posted. The only changes we have to it, and it's actually not reflected on this slide, but the only changes we have are in speakers. Unfortunately, Norm Finn can't be with us today. We hope to see him in Montreal. And so we have someone else presenting, and we have a change in presenters on the flow information draft. I believe Balazs will be presenting rather than Janos. As always, the mailing list is there for a few things. It is where we establish consensus for the working group. So anything that we say here, any decisions that we take here aren't in fact decisions until they are confirmed on the list. Also, it is the right place to introduce a draft. This is not the right place to introduce a draft to the working group. You should do it on the list and get some good discussion on the list. And it's far more likely that if you have something, a new contribution, it's far more likely that you'll make progress with that contribution if it's first discussed on the list. And to authors, I'd like to remind you that authorship, we really appreciate your contribution. Having private discussions to help move the ball forward is fantastic. But no change agreed to by authors are final until they're agreed to by the working group. So it's great that you have agreements on the among the authors, but that's not the valuable place. The valuable place is the working group, and the list is the right place to confirm that. We do have an IPR disclosure process to make sure that we have appropriate disclosures on, and we check that at sort of 2 wickets. One is a document is adopted to the working group, and then the second is before we go to last call. These IPR polls are directed to authors and contributors named in the draft, but it's really to everyone in the working group because everyone has an opportunity to contribute to this. Just because you're listed on the draft doesn't mean you own the draft. The working group owns the draft. So it's your draft, so please contribute. And if you contribute, please do make sure you conform with the IETF IPR rules. So where do we stand on our different documents? We have 2 documents with the RFC editor. This is fantastic. These are our first set of documents that are finally making out to into the RFC editor queue and will be our first documents published as a working group. It's taken us a little longer than we had wanted and we had hoped for, but we are starting to see things make it into the ISG and make it into the RFC editor queue, and we'll soon have RFC. So that's fantastic. We really appreciate all the hard work of the group. We have a document, the architecture document is with the ISG. There was a number of questions placed on that document, notably from the security area. We really appreciate all the hard work of the authors and also the authors and contributors to the security document who helped come up with some text that improved the document as well as address the original comments from the ADs. So we're hoping that that also has passed the major hurdles for approval, and in short order we'll make it into the RFC editor queue as well. We have a number of working group documents on the agenda, so we'll be hearing about those shortly. Not on the agenda is the security document. We've been holding that up to make sure that we don't, to make sure it's well aligned with the solutions, and that if we find something in defining the solutions, we don't have to reopen the security document. You'll hear later that we hope to be getting solutions documents popping out of the working group being submitted to with publication requests to the ISG by Montreal. If that does in fact happen, then maybe it's time to think about that we submit this one as well. But it doesn't have to be the first document. So we should keep this in mind and think about maybe we'll be doing this along with those other documents or soon after Montreal. This is just a reminder. I think everyone is familiar with this. We are starting to deliver to the IESG for publication on these pieces. The one thing to think about is where we go next. We're not quite ready to talk about that. We need the documents actually to make it into the IESG, but we've had a number of discussions about whether we go to control plane or start bringing in, there's other topics, and we'll get to one later about what things that are in scope or out of scope. But if you have other topics you think are appropriate to bring into the DETNet working group, perhaps Montreal is a good place to start thinking about that or talking about that. Not everything is within the scope of the working group. It's important to look at the charter and understand if you bring something new to the group, that there may be another place in the IETF which is the right place for that. But you can bring things and we'll discuss it and figure out where to go. And of course, those discussions happen with our ADs in the room, Deborah, as well as our advisors, such as David, who I see David Black sitting right here. So I think that's enough on that. Oh, with that, we're ready to move on. János is going to talk about DETNet architecture. I have no idea how to get out of this. Oh. How do I get out of this? Thank you. I got it.
Okay, as Lou mentioned, the architecture draft is with the IESG, and we had updates to address the comments. This presentation summarizes the major or the main updates we have made since the publication request, which was actually on version 8, and now we are at version 12. Actually, there was two groups of review comments. On version 8, we got the reviews from the various areas of the IETF, and then on version 11, the IESG review comments. These links in the slide lead you to the two ways of showing the diff between the two versions, version 8 and version 12. If you are interested in the details, you can check. The order of the updates described in this presentation is based on what had a major effect or bigger effect in the document. The first category of the updates was to clean up the document in order to avoid confusion with the terminology that is used in the transport area, like the word transport itself and congestion control and so on. So one of the big steps was renaming the former transport sublayer to forwarding sublayer. So the figure is copied from the draft. We divide the DETNET layer into two sublayers, and the lower one is the forwarding sublayer. The upper one is the service sublayer. Another big terminology change that had an effect on the draft was to use the use of resource allocation instead of the former congestion protection. So both these changes, as I said, is to avoid confusion with the terminology of the transport area. This text in the bottom is copied from the draft. The three main techniques we use in DETNET with this update is the resource allocation, service protection, and the explicit routes. There were further clarifications related to congestion control. So we had to talk about, okay, what if some flows are under congestion control as RFC 2914, and we have added a text after discussions on the list to address and clarify these aspects. Actually, this presentation is populated with links to emails. I tried to capture. Of course, I could not capture everything because it was multiple email threads. But if you are interested, that's where the links lead you. And further clarification was added related to congestion control, that there is no expectation for the DETNET flows to be responsive to the congestion control or explicit congestion notification. So this is the new phrasing in the draft, how we make it clear that we don't expect congestion control to be used for DETNET flows. I copied the principles we had behind those updates because it was multiple rounds. First we got rid of the terms transport and congestion control, and then we had to add it back. And for that, we didn't want to introduce any new term. We wanted to minimize it, adding back congestion, like the term we have removed previously. And we removed phrases like throttling that were not clear. So these were the updates related to the congestion control or the transport area terminology part. And
Janos, excuse the interruption. Do you mind going back one? There's a really important implication here. There's a ripple effect, is that we end up, and tell me if I'm jumping the gun, we end up having to, at the sort of service interface level, understand whether or not the application traffic is supports congestion control or not. And that has a ripple effect down to our flow model, to eventually our Yang model. And that's something that we hadn't really had before, was awareness of something related to the application. And the reason for that is as part of addressing this, and I think you may hit that later, is that there's some extra text on some requirements that what we have to do for traffic that is not congestion controlled.
Yes, good point. Actually, this is the introductory text, and we have further text.
So I'm jumping the gun. I apologize.
So I'm kind of worried about that, because people used to throw that rock at us in the pseudowire working group, and we pointed out that the amount of traffic that went in the open that was not congestion aware was trivial, and we managed to avoid doing it. Because in the cases where it is congestion, or congestion causing, I suppose, or non-elastic, it's in a controlled environment. I hope we're not going to require sort of full analysis of all the applications before they can
No.
be deployed on this network?
No. What we did is, as Lou pointed out, it's coming in the next aspect. That
Well, I disrupted your flow. Do you want to wait until you get there?
So two points. This is as the charter says, and this is one of the clarifications that we are for a single administrative domain. So it's a kind of controlled environment. Plus, we added text to make clear rate limiting and use of shapers and so on. And that's all you need. You don't have to know every flow or everything like that. It is these rate limiting tools that you use to have protection against misbehavior and stuff like that. And you use it in the input to the DETNET domain.
So why does it have to be a single domain as opposed to a set of domains that understand what they're doing?
We're following our charter.
Well, maybe we need to revisit that, because it seems unreasonable that you can't split your area into two, your domain into multiple components if that suits you.
Maybe we can add that extension in the charter update. I guess it's good to wrap up the work with the current charter first, and then we can make enhancements later on.
I guess people will just ignore it if they don't like it.
Okay, back to the slides. Another big change, as Lou also mentioned, is actually we have rewritten the security considerations section based on the review comments we got from Security AD, and thanks for all the help on that. I think it is an improvement. It is a lot clearer what, from architecture perspective, what we are after. And a somewhat related update was to the privacy consideration sections, where actually the clarification was to make it clear that DETNET doesn't bring in any new privacy considerations. So there were two updates to make that clear, again, based on IESG review. One of the comments was from the Security AD. Another major subject was that what are the capabilities of non-DETNET nodes? What about non-DETNET flows versus DETNET nodes and DETNET flows? And multiple clarifications have been added to this extent, to the introduction, and then different sections on what do we expect from non-DETNET nodes and where they can appear in a DETNET deployment, and also what are the expectation on non-DETNET flows, or what are the non-DETNET flows. And this leads to the other topic that had multiple updates on clarifications for the protection of non-DETNET flows against DETNET flows. So how do we make it sure that some bandwidth remains for non-DETNET flows and stuff like that? Protection against misbehaving devices or misbehaving flows, whether or not DETNET or non-DETNET flows. As I mentioned before, the key thing here is the rate limiting and the shaping functions we have at the input of the DETNET domain for DETNET flows. And this was another text added for the protection of the downstream hop after a DETNET domain. So these were the updates related to malfunctioning misbehavior. And compared to the previous one, there were smaller updates on clarifications related to definitions and terms. Definitions have been updated, like the app flow, the DETNET flow itself. These are the most important ones. That's why I copied them here. And we have multiple types of DETNET nodes. In version 8, it was not clear. We have clarified actually the definition plus the use of these terms throughout the document. And correspondingly, we added an umbrella term, the DETNET node, if we don't want to go specify whether it's a transit node or relay node or what specific aspect. So this was smaller updates throughout the document. And the DETNET sublayers, I mentioned the terminology change, and actually, in addition to that, the definition was extended to make it clear upfront in the definition that DETNET has 2 sublayers, and the reader doesn't have to jump up and read that section with the figure I copied, but it's obvious from the definition that, okay, we have 2 sublayers. One of them is the forwarding, one of them is the service sublayer. There was a reordering of the definition to make them in lexicographic order. And there were comments to clarify the scope. This was on version 8. As I mentioned, that based on the charter, we are for a single administrative domain.
So I think we would serve ourselves much better if we had said that within a controlled domain and not in the open internet. And the reason I say this is that one of the things that we did after learning from our pseudowire sort of heritage, as soon as we'd done pseudowires, which were designed for a single administrative domain, we had to do multi-segment pseudowires, which are definitely not a single administrative domain. And I can imagine that such things will be needed in DETNET as well. So I think the important thing is that it's one or more controlled domains, not a single administrative domain, which has its own set of restrictions.
But if it is, let's say, 2 controlled domains, are you looking after having different owners of those?
Yes. So for example, in multi-segment pseudowire, one of the reasons for introducing it was so that the tags could be managed by each, or the labels could be managed by the domain separately. So I think we would serve ourselves much better if we pointed to the real problem here, which is that this is about control and oversight of the deployment, and not about the restriction to a single administration.
So I think it's worthwhile to go look at the text, the actual text of the document, and see what's in the body of the text, see what's in the different consideration section. I'm pretty sure that the only place it uses the word single administrative domain is when we're talking about security. And the rest of the architecture talks about, I think the exact quote, it's not for large groups of domains such as the internet. So I think we can probably all agree that DETNET is not for the large groups, a domain such as the internet. That's actually stated in our charter, and I'm not sure that we're going to have any contention there. Now, the point about whether it's limited to a single administrative domain or not, I'll point out, look at the document and read it in context, please. Deborah.
Deborah is speaking with both hats, because this comes up all the time in the ISG, and also as an operator participating in the many groups. This is really a hot button item, domain. What is the domain? And you could even say a DETNET domain crosses multiple administrative domains, as Stuart's pointing out. The most important thing is it's a controlled domain, right?
Yeah.
Or actually, like you're even saying, subnetworks may not be DETNET aware, and you can still get across them. So I would say, Stuart says, that rethink this just a little bit, and if in the security sections you have administrative domain, I'd be a little bit worried about that one too. So I think just give it a couple of thoughts more before deciding.
That's good. I need to.
This is the document's now owned by the ISG.
Yes.
We have a version out there.
But these are definitely not technical changes. These are clarifications. So we just got to get it right. Like you said, the charter is pretty clear, so most important is you don't want to say it's the open internet, and right?
So I'm realizing I need to apologize. It may be my fault of using the term single administrative domain. So the text we have on the screen is the text what we have in the document, in the body, and this is the text what we have in the charter. So what the text I copied from the introduction here is copied from the charter to the document. And it doesn't say single administrative domain. It says a closed group of administrative control. That's what it says.
Okay. Oh, okay.
I
So
am-
that
I'm
gets-
sorry, this-
That gets
Except-
close to the story.
Except in one place. In
Yes,
the
that may
security,
be-
in the
yes.
security consideration section, it talks about a security consideration about an intent of a single administrative domain. That's in the security consideration section. It does say that.
Well, how about swapping that with like Stuart's word, control?
We may consider changing that wording to this wording, what we have here.
Because I would say administrative control, closed group of, it's, it's
So-
cooperating administrative.
Replace the word single, and replace domain and single administrative domain to single administrative control.
Yeah, something, or closed group administrative
Yeah.
control, something, get away from the word domain. That's just a hot item.
I'm very careful. I'm very worried about making any change, like even at this level, given the discussions that have happened with the IESG. So we have to make sure that we're really well coordinated with you. And we
Yes.
have to be very careful here.
Yeah, well, if for some reason they want, well, just if they push back on removing domain, I'll just say we all know this is very confusing.
So sorry, Stuart, who keeps forgetting to identify himself. I think that the text under you've got introduction extended, that scoping there of single administrative control or within a closed group of administrative control is very reasonable and sort of sets out what we need to do. And maybe we should make sure that scope is reflected everywhere where there is a constraint.
It's the security section we need to double check, because actually that was the one that gone under a major rewrite based on the IESG comment, and we may have not noticed that we should have been more careful with this in that part. But we did pay attention in the abstract and in the introduction upfront to be in line with the charter, and we were careful in the charter, as it turns out. So this is a text. Okay, thank you for that feedback. And there was some discussion and clarification on the priority queuing that how it relates to DetNet. I just thought to mention because it was multiple emails with multiple people, and a number of references have been added based on comments. I listed them here, and there were further smaller updates. These links actually lead you to the announcement of the different drafts, which emails summarize what changes have been done from the previous version and provides the links to the email discussions. So this is it.
David Black, first on behalf of the transport area, thank you for the changes here, massive improvements to the current version over what you started from in 08. Also want to briefly follow up on one of Stuart's comments. It should not be necessary to individually analyze applications for congestion control or the lack thereof. Rather, there's some fairly obvious DetNet use cases that aren't congestion controlled. Broadcast video for video editing is an obvious one, and I can think of several more. The paradigm to apply here is that unless you know it's congestion controlled, assume it isn't and take appropriate measures. And that applies doubly if you're doing packet replication and elimination, because with packet replication, if one of the two or however many replicated flows you have escapes, the elimination node may not notice that it's only receiving the other flow, which means I've now got this completely non-responsive flow going out and causing damage. But in general, you should not need to do the application analysis. Just if in doubt, assume it's not congestion controlled, take appropriate measures at the boundaries.
Yeah, for that particular issue you just raised at the end, this is a text we developed together with you.
But that's an excellent point. And the place where that'll impact is the Yang models that are being developed. So first of all, we have to add in a way to configure or to indicate this. So we don't have that right now. We can make that optional with a default value of true, that it's not, sorry, I guess that's false.
You right. Make it optional, default to not. I mean,
Right.
if in doubt, treat it as a potential source of problems and deal with them. And then if you have no problems, things are even better.
Yeah, so that's very helpful. Thank you.
Okay, thank you. And the next one is Balázs. I guess we don't have this ping box this time, but we have a ping cross. So
somewhat interesting, but okay. My name is Balázs Varga. I would like to give you an update what has happened in the data plane solution document. So there we have a pretty big improvement, I think, regarding the change from the previous version. So let's summarize it. So in these slides, I will go through the changes in both the IP and the Mpls data plane solution. But before going to that, we had some discussion regarding the document structure, and this is where we would like to ask for some feedback from the group. And of course, I will finish with the next step slide in order to show what improvements we intend to do in order to reach the Virgo Plus goal and finalize the documents. So before going to all the changes, let's see to a question where we need some input from the Virgo. During the discussion of the different DETNET scenarios, we have identified in the document several scenarios. Some of them were how a flow is mapped to a DETNET data plane and how it is served. Some scenarios were focused just purely on the DETNET data plane in order to what processes are needed for the different DETNET functions. And some of the scenarios were focused on how to interconnect with a subnetwork to DETNET nodes. So based on this discussion from the scenarios, we concluded that there is a basic question. And it is, are we specifying building blocks or solution? And this is also translates how many documents at the end we need in order to describe the data plane. In IETF, generally, we are defining building blocks. And this is, for example, the scenario with the Mpls data plane. And it was defined without any description of what is carried in Mpls and how Mpls is carried over any specific technologies. So a similar analogy can be used also for the DETNET data plane. However, some other organizations are specifying solutions. So this is the question. In the current approach, we have two documents, and based on the structure, we need some feedback. And this is what we have summarized in this slide, where we are currently and what would be the proposal for the further improvement of the document. So currently we have two documents. One is dealing with the IP data plane solution, and one is what is dealing with the Mpls data plane solution. And they are the drawing in the upper right corner. This is just trying to highlight what is there inside those documents. So we have core data plane related sections dealing the DETNET IP and the DETNET Mpls. We have sections dealing with mapping of core data plane to underlying transport, so TSN, IP, Mpls. And in the Mpls document, we also have some text covering TSN interconnect over Mpls scenario. So if we intend to take the building block approach and follow how Mpls-related RFCs are defined, then the proposal would be to split these two documents in maybe 7 different documents. The first two would concentrate only on the DETNET IP data plane and Mpls data plane, and maybe also framework-related stuff. The next 4 would deal with how DETNET over different subnetworks can work. So when you are interconnecting two DETNET nodes over a subnetwork. And the 7th document would deal how TSN can be provided over a DETNET domain. Regarding the framework, this is something that might be published as a separate informational document. So we think this is something that can be decided best during the split of the documents. And if we look to the current document structure, it is really supporting that split. So we have dedicated chapters dealing with these topics. So we think also that after the split, some of the documents will be practically finished and can go to workgroup last call. So in the next slide, we have just summarized what would be the result of the split and what is achievable before the Montreal meeting. So the split and publish the drafts, this is valid for all of the documents. And we think that on 4 of the drafts, maybe it is possible to reach the workgroup last call before Montreal. The 2 documents which would dealing with how a TSN subnetwork can be used for IP DETNET or Mpls DETNET networks. This is something where we need some further clarification discussion. So we put there a question mark. And regarding the TSR over DETNET MPLS document, this is what needs some further improvement. This is where we need some more stuff to cover there. So
when you're ready, you have Norm in queue, just when you're ready.
Okay. I will stop here for a moment to collect feedback from the workgroup. Any feelings, comments, questions regarding that split? Let's have Norm.
Hi, Norm Finn, Huawei. I think breaking the documents up sounds like a promising approach. Do you have any comments on how we address zero congestion loss, finite latency for the, I know how we do that in the TSN parts, but for the parts that are not over TSN, how do we tie that into the document structure?
Perhaps this is not the subject of this document structure to provide that detail. These are the data plane documents or set of documents, and the bounded latency document, I would see that one as the one providing this aspect of that.
Okay, hopefully it can do that for all of them. Thank you.
Right. Norm, certainly the items 3 and 4 would, 3, 4, 5, and 6 would need to talk about requirements on the underlying layers for providing those queuing mechanisms.
I see.
Generally, this group doesn't define queuing mechanisms, but we do define how to use queuing mechanisms, or that an implementation is required to use a queuing mechanism. If you think back about how inserve has been defined, how diffserve has been defined, the actual mechanisms within the node to achieve the service isn't defined or isn't required by the IETF. Just the behavior on the wire is required.
Thank
so
you.
I'd expect.
Very helpful.
Okay.
David Black, a question. Where will the hitchhiker's guide for the uninitiated be located so that someone can figure out which of these documents apply to what they're trying to build and how to put them together?
Where does that apply for the IETF, for the internet, for any of our technologies?
This working group claims to be building a single overall technology. There are almost certain examples that I can cite that are at smaller scope. That means, for example, we in transport wound up having to, after the fact, write a guide to all the various TCP specs. I might suggest being proactive on this one before you encounter confused implementers would be a good move.
Good advice. Thank you.
Okay, and so the question is where to put that.
I think that's another document. I don't think it would be in our specifications.
Okay.
That's the question I have as well. That should we have a zero document giving this guidance, like the data plane summary document and giving the lead to the different pieces. Because the idea behind the split, as Balázs explained, is to follow what we are doing in the IETF, in Mpls and so on.
Yeah, my name is Michael Scharf, and I'm the reviewer of the architecture document. So when I read the architecture document, I actually noticed that you have quite a bunch of different architectural solutions. And in the architecture document, you mix all of them. And that actually made the review pretty difficult because there are all these different solutions. So this, to me, somehow speaks in favor of separating the different ways how you can build a DetNet into separate documents. So I think that is maybe a good idea. Nonetheless, please pay attention, and the transport area will carefully look at the implications of that. So please be proactive on that. But in general, this looks to me like a good idea based on what I've seen in the architecture document.
Yeah, in the architecture document, we have several scenarios, and they are covering all of this. That is causing
exactly. But for the things, for example, that we had to discuss, you have seen that I had to distinguish clearly between some things that, for example, apply in the Mpls case, other things that might not apply in the Mpls case, and some of these things are probably easier to sort out in such a splitted architecture.
Agree.
So to answer, Stuart Bryant, to answer David's question, well, some of the clue that you'll want presumably will come from the framework component of the first two documents. That will set up some of the structure and some of this information that you need to as forward reference. And second, to the second part, when we've got these together and seen whether any more of it needs to come together to do the data plane, then is the time to write the summary document, but not until we get a bit further along the way, if it's a sort of cookbook type of book you're looking for.
Deborah, speaking as your AD, I think it's really good that you're thinking about this now, and because for some of the other technologies, it creeped along, right? And then it came about as it was. And this is very daunting when you first see it. And, you know, that you can think that, well, 2 documents are going to become 7. But looking at it very carefully, I think it does look much more clearer and separated. And always, as you know, think about your users and what they're going to be looking for. The only thing I would say is that the user won't they will see these titles there, and that can, I think, maybe be daunting. So I think just try, maybe you can have the 7 documents, but try maybe carefully to think better of the titles, because right now it just looks like that you're throwing together, you know, and putting DetNet either before or after or in the middle. And it can be very confusing if one would see this all on a list like this. So I think just think a bit more carefully on the titles and how you would do it.
Yeah, I agree. We need some work on the titles.
I could even say
Agreed.
maybe deterministic Mpls over. Yes, I know. And so I think it's very good you started thinking about it, and just because we don't want this to look like you threw a bunch of blocks on the table and combined them, you know, and put DetNet random places or something.
Okay.
Andy Malice, yeah, just as one of the people who've been writing text and contributing to the existing 2 very, very large documents, you know, reading through them is a chore, and I think that this will go a long way to making the work more approachable for people who haven't been following it day in and day out as well.
Thank you.
Mark Chen. So I have a question about this document splitting. Is this splitting is just based on the current 2 data plane draft, or maybe you can consider more consideration to consider other potential data plane, for example, the SR-v6 based solution?
Okay, so this table is based on splitting the current 2 documents. That was the first idea, because that is where we have the structure And this is where we think that this result can be the result as shown now on the slide.
We have a presentation on SRv6. I suggest to come back to this discussion related to that presentation.
Yeah. Exactly. This is what I wanted to highlight.
I
That this
think
is
it
the
makes it
minimum
easier
Yeah.
for future technologies
Exactly.
because then it's just yet another document as opposed to having to hold a base document until all the possibilities are there. So I think it actually makes it much cleaner to bring in newer technologies or other technologies.
So based on the current 2 data pane solution, these 7 we have identified, but further documents may exist and can be created.
Okay, thank you.
Okay, so thank you very much for the feedbacks, and maybe let's look to the details what was changed in the data pane documents. Let's start with the IP solution document. So we had here some terminology cleanup, and there are new content in chapter 5 on management and control consideration. Of course, it is out of scope in this document to define the controller plane for the DETNet, but these are from DETNet data plane discussions, what implication, what consideration should be done for the management and control. This is just the starting list. When we will later on discuss management and control plane, this list can be extended. So the content is about flow identification and aggregation, explicit routes, contention loss and jitter reduction, bidirectional traffic. And then in chapter 5.5, we have summarized from the data plane definition, derived controller plane requirements. We have a new chapter, chapter 7. It is describing the IP over DETNet MPLS. That I would say that this text, which was practically copy-pasted from the MPLS solution document, was the last trigger for us to think about a new structure and what we have discussed in the previous some minutes, how to have a better structure for these documents. We have update on chapter 8. Chapter 8 is dealing with mapping IP flows to TSN network. Here the procedures were updated and also the management and control implications. And this text is describing the scenario where a DETNet node is treated from the TSN subnetwork perspective as a TSN-aware talker or listener. Regarding further work in the IP document for the OEM, which is chapter 4.4, we have no content currently, but there is also discussion about OEM related stuff. There is also a OEM individual draft. So this is something that would be good to cover in a separate document which is dedicated to OEM. And we have also some further work, some clarification needed on the TSN as a subnetwork chapter. So this is something that should be improved or should be changed in the content. And of course, the document structure, as we have discussed, we do not intend to make those changes in the existing document, but in the documents which we are resulting after the split. And of course, a general editorial cleanup is also something that is needed for the document. So these are all the changes regarding the IP document. And let's look to the MPLS document, what was updated there. So there were, again, a terminology cleanup. There were also many editorial changes. So thanks for the native speakers review that improved the text pretty much. So we have editorial changes in chapter 1. Chapter 4 or 5 are candidates for this restructuring. So this is what is identified there. We have changes in chapter 6, and that is an important change in the document. For the MPLS data plane encapsulation, the encapsulation regarding the DETNet encapsulation, it includes both the S label and the F label. And that was a result of the discussion how the S labels should be allocated, whether they should be allocated for a per platform label space, like in case of pseudovirus, or they can be allocated differently from that. And it is implementation specific, your decision how you are implementing this and how you are allocating the S labels. So here in the figure with that red circle, we have highlighted what was changed as a vision. So the F labels were added also to the Mpls DETNET data plane encapsulation. There is also a chapter on controller plane, so management and control plane consideration. It was filled up with content, and in chapter 9, which is dealing how DETNET Mpls operate over a DETNET IP network. Here, because of the F labels are part of the DETNET encapsulation, now the UDP IP headers are also part of the DETNET encapsulation, similarly as it was shown on the previous slide. We are quite happy with the Mpls data plane document content. So most of this stuff is, we think, almost ready for a workgroup last call. So after making the document structure change, this is something that can go for this workgroup last call. Okay, just a slide to summarize the next step. So the proposal was to split the documents in multiple documents, finalize core content, and for 4 of the documents, we are intending to have almost final version and going to workgroup last call. So this is the current state. Any questions, comments? Okay, happiness. Let's jump to. Okay, so these slides are showing the update on the DETNET flow information model. Here we are now with version 3. There are only small editorial changes in the document, and there are also some questions consideration where we would like to have some workgroup discussion and feedback. So this is what you will see in these slides, but where we need some further discussions, what were explicitly the updates in the version 3, and what are the next steps. Just as a reminder regarding the service flow and configuration, we have defined 2 documents in order to deal with that. In this document, we are dealing with the flow information model, which describes the characteristics of data flows. It includes in detail all relevant aspects of a flow that are needed to support the flow properly by the network between the source and the destination. And we have here also the service information model, which describes the characteristics of the service being provided for a data flow over the network. And it can be treated as a network operator independent information model. So these 2 models are there intended to be there in the flow information model draft. And the 3rd model, which is related to configuration data model, this is where we have the young drafts. And they describe in detail the settings required on network nodes to serve a data flow properly. Just based on the latest architecture draft, some reminder on the flow definitions. So the app flow means the application data without the DETNET added headers. And the DETNET flow is defined as the app flow plus the DETNET encapsulation. Please note that the DETNET encapsulation may simply reuse the app flow header information within the DETNET domain. So like this is the case with the current DETNET IP data plane solution. When we are speaking about DETNET flows, we have some further terminology as well. So when we are having protection, replication, and elimination inside the network, Then we have them .NET compound flow and .NET member flow. And we have also defined in the .NET data plane aggregation. When aggregation is done, then it will result in a new aggregated .NET flow. This is similar to what we have in MPLS hierarchy. So the target for the flow information model is to have a little bit better structure, which is consistent with the architecture and the data plane draft updates. So from attributes perspective, we are quite stable. So we have, I think, almost all of the attributes defined in the document, which are needed in order to describe the flow information model and the service model. However, a little bit better structure, grouping of this attribute, this is what is needed to be done as an update in the document. And in order to make that change and find the correct structure for the definition of the attribute sets, here we have highlighted the three major functionality points where you need information in order to make the proper .NET functionality and processes. So at the age node, you have to identify the flow and create the .NET flow at the age of the domain. Within the .NET domain, you would like to serve the .NET flow according to its requirement. And when two .NET nodes are interconnected using subnetworks, this is again a point where you need .NET flow and service-related attributes in order to make that mapping properly. So when we are looking to an end-to-end service, then we can define four sets of information groups. One is describing the app flow. Then the app flow will have also some service requirements. So what parameters should be provided when the connectivity is there for the app flow. The app flows are mapped at the age node to a .NET flow. And this .NET flow will be served with .NET service attributes within the .NET domain. So these are the four sets of attributes that can be identified. And here in the bottom of the figure, we have also highlighted which set of attributes are needed where inside the .NET domain in order to have correct .NET data plane related processes. So that is the intention, to have this structure of the attributes which are already defined in the flow information model. So app flow and service requirements, they are limited to the age node related functionalities, because this is what you need at the age of the .NET domain. Inside the .NET network, you will have the .NET flow related parameters specifying the flow itself, and the .NET service related parameters which are defined in order to provide the .NET service for the .NET flow. So that is the intention, to have this structure replicated in the document. And as I said, we think that the attributes are already there. They are quite stable since the version 1 of the document. And we think that maybe 99% they are ready. So maybe some fine tuning are needed, or maybe we have a missing attribute somewhere. So any feedback on that attribute list are also welcomed. So the update on the text itself, there were some terminology cleanup, and we have added a to-do list section at the beginning of the draft in order to highlight what changes are needed in the document in order to getting close to a final version. That's it. Any questions, comments? Okay, so if you are happy with that, that is something that should be reflected also in the Young model later on, I think. Okay, thank you.
And speaking of Yang models,
Okay, good morning, everyone. And I will introduce our work about DETNET configuration Young model. What we have done after the last IETF and was in the plan. Actually, we have talked a lot about how complex the architecture document and the data plan document. I have to say that the configuration model is also complex, and it is really a tough work to make it simple and easy to use. So please join us if you are interested in how to configure the DETNET network and make it work in a real network. And here is a brief history of this document. In the first version, it is version 0. It is accepted as a working group document after IETF102. And the first version, the IETF DETNET topology Young is defined separately. And in the second version, the newest version, the document is updated following the feedback from the working group. We end the sequence number generation to satisfy the requirements of the OEM. And we also end the DETNET service decapsulation and transport tunnel decapsulation. And since there are some changes of the topology in the architecture document, so the architecture of this document in the next version will be updated too. Actually,
when you do that update, it'll be really good to synchronize with Balazs and the other authors of the flow information.
Yes.
They're changing the structure, and my bet is the changes that they make are going to need to be reflected in this document.
Yes.
And so work with them before even the document, the next update comes out.
Yes, and perhaps I know there is a design team and there is some call meeting for the data plan solution document. Perhaps we can have some similar working mood for the flow information model and Young model if
Yeah,
it is necessary.
That's great. The design team is over because it became working group documents. So now we just have people who are contributing, and
yes.
so talk to the authors and set up. It's perfectly reasonable to set up calls to get like high volume exchanges,
Yes.
and of course the results come back to the list.
Yes.
But
Okay.
yeah, just contact them and work with them. That'd be
Okay,
great.
okay. I think it's quite necessary. And we can see the structure, continue. Actually, the attributes defined in this document, we think it almost covered all the attributes that are needed for configure a DETNET network. This is one side, but on the other side, how to organize these attributes, make it simple and easy to use is another topic. So we want to, in this presentation, we want to list some options for how to organize the attributes. And this is option 1. It is what it is look like in the current version of the draft. We can see that the configuration of the attributes is organized based on the role of the DETNET node that are defined in the architecture draft. There is transit node for queuing and filtering, and relay node for service protection, and ingress node, egress node do some mapping between different DETNET encapsulations. And the Young models of different data plan solutions are also supposed to be defined independently. We will have IETF DETNET Mpls Young model, IETF DETNET IP Young model, and we can see that there will be a lot of data plan drafts in the future, as we have already discussed. Perhaps this will make it really complex to do the configuration this way. So we consider that maybe this structure is complex and difficult to do mapping between different encapsulations. We want to make it more flexible. So we have another option. all the attributes of different DetNet nodes are defined in the same structure. We divided into two groups, in segment and out segment. And all the functions for the DetNet are divided in these two groups. And if we configure some some specified node in the network, we just choose the necessary attributes from this structure. And also, we also want to define all the data plane encapsulations based on the same structure, and which will make it easy to do mapping between different encapsulations. But we are afraid that this maybe go to another extreme, that we make the structure too simple and it is difficult to use, because all the attributes from different sublayers, we put it together, and maybe when we configure the network, it will make it very hard to understand which attributes should we use. So we try to learn something, what has been done in IETF. This is the structure of IETF Mpls static YAM model. We noticed that there is in segment, which is the incoming label actually, and there is an out segment, it is the outgoing label. And there is an option for the label, pop, push, or swap. So maybe we can make the DetNet configuration similar to the Mpls static YAM with some modification. And the same structure is showed here. There is in segment, there's out segment, and there is operations for DetNet node. And the in segment and out segment are not only labels. It can include different DetNet encapsulations, including MPLS, IP, and maybe SRA6 in the future. And we also define new operations rather than label operations, swap or pop or push. There will be operations for service protection and congestion protection. Maybe we have to change the terms to the resource reservation. And this structure will support the functions for DetNet, and it also can support the flow aggregation, make it simple to do the configuration. So here, here are some options we list in the slides, and we need some feedback from the working group. Which structure shall we choose for the next version? And another legacy question, whether a DetNet queues is in or out of the scope of DetNet working group, whether we should include some, it is showed in gray in this picture, queues algorithm configuration in the YAM model, and more comments and contributions are always welcome.
I have a question to you as one of the people who have gone through this analysis. Out of the three options, do you have a preference yourself?
In the current stage, I think this one may be more clear and easy to use. What do you think?
Yeah, I do think a reorganization is very helpful.
Yes.
I still think that we have more work to do to align with what's going on in the flow information, as well as the new terminology in the architecture. I think the architecture clarifying what's now called the service and forwarding layers is very helpful, and that's rippling down into the flow information and document. And then I think that'll have to ripple down into here. So I think the reorganization away from, as you've identified, the organization on a node basis really is cumbersome and doesn't work very well. So reorganization away from that, I think, makes a lot of sense. But I think you might want to synchronize with the flow information and align with what's in the architecture and the flow information with the notion of this service and forwarding sublayers. Once you're there, then you can start thinking about like what's going on in the data plane document, that we have a core piece, and then we have other pieces that sort of get bundled on top of that. And maybe that turns into augmentations, maybe that turns into pointers into other things. And when you start thinking about it, also look that we have a lot of work going on in T's, which parallels this. And we don't want to repeat all that work. So the question is how to integrate with it. Do we augment the T's models? Do we figure out how to reference the T's models? So I think that there's still, to some degree, these are still early. And there's, I think, a fair bit of synchronization that has to happen. and that will help clarify which option we end up with. I think moving to 2 and 3 is definitely good steps.
Okay.
Whether it's 2 or 3, I think maybe it's a little early, at least from my perspective.
Yes, I agree. And I think the point is there should be more cooperations between these works, between the configuration and the flow model and the, perhaps also the architecture and the data plan solution, all
Sure.
these working group documents. If we work together, the synchronization will be really efficient.
Yeah, maybe we can figure out some time. I mean, it's just Wednesday.
Yes.
Maybe we could figure out some time to get the groups together to talk.
That would be great.
Yeah, that'd be really good.
Okay.
My name is Yancha Ryu. In my opinion, option 3 is better aligned with Mpls Young model definition. I'm support of option 3.
Yes, actually, we have collected a lot of useful comments from Yuan Chao, and I think it is really helpful if more people can get involved in defining this young model.
David Black got up to quickly +1. I think it was Lou's comment that both 2 and 3 are better structures than the node-centric structure of 1.
Okay, thank you. We are moving forward. Okay, thank you.
So Sean? So Norm is online, but not here in person. And we have Eshan Mohammadpour.
Okay, this is Esam Mohammadpour from Swiss Federal Institute of Technology, EPFL.
You have to get.
Okay, can you hear me? Okay. With our latest update over patent latency draft. So a reminder for the new attendees, the goal of this draft is to provide an upper bound over end-to-end latency, and not just not the lower average delay calculation, and also providing zero congestion loss by providing enough buffer size inside each node. And we find it nice to prove these two requirements mathematically. Well, there are major changes from draft 2 to 3 that in Bangkok we've decided to make this document informational, and we made it. In section 3, we added a new part to address the dynamic and static flow creation. As we discussed in Bangkok, there were some requirements to add dynamically or remove some flows from network. We added section 6.4 to update delay bound calculation for per class queuing with asynchronous traffic shaping. And the flow admission control is added in this section as well. We simplified some parts regarding the int-serve to be easily followed by the people who are reading, and remove some too much mathematics from this section. Well, in section 3.1, there were two type of flow creation is discussed. So the main thing is that we have two types of flow creation, a static one, where we have all the information regarding all the flows at the same time, and we do the admission control for all of them or none of them. And so this has been addressed in draft 2. But what is done in draft 3 is to address the dynamic flow creation. It means that if a flow is entering a network or leaving the network, how do we manage it? And we found it that there are some kind of requirements to be added in this draft. So what we are going to discuss is this dynamic flow admission. So in the per class dynamic flow admission decision process, what we have is there is a node when we define two types of capacity parameters, the total rate that is allocated and the total burstiness. And for each flow entering the network, there are two parameters as well, the rate and the burstiness of this flow. there are two counters within each node, the accumulative rate and the cumulative burstiness. There should be less than the capacity of the burstiness and the rate in this node. So when we want to have a flow admitted, we should guarantee that in all the nodes that this flow is traversing, these two equations hold. Well, the rate that the flow wants plus the cumulative rate should be less than the capacity of this node. And as well, this should hold for the burstiness term. If one of these equations in one of the nodes that this flow is traversing is not holding, then we cannot accept this flow because we cannot guarantee its requirements. Well, as soon as we accept this flow, we should update these counters, and this can be done by just easily adding the rate of this flow and the burstiness to the corresponding counters. And as soon as a flow leaves, we should subtract these two parameters from the accumulative rate and burstiness. Well, are we able to calculate end-to-end latency bound for that? Well, this is the model of the relay node inside DETNET, that we have the combination of regulator and queuing subsystem. The parameters to calculate end-to-end latency bound, well, we have it as the combination of the queuing subsystem and the regulator at the next node. With thanks to the re-regulation for free property, we are able to calculate per hub delay bound, where the parameters you can see in the formula are fixed, and just we know the information, the total burstiness, the delay, and the rate term of the queuing subsystem, and the C is the transmission time. So we are able to calculate a delay bound over one hub. And simply by just summing this per hub delay bounds, we are able to compute an end-to-end delay bound for this specific flow. Well, there are some updates that we're planning to go through it, and one is to improve this delay bound calculation, and we think that we are able to do that, and from both the dynamic and the static flow creation or problems. As well, there are some work related to CQF, since this work is intentionally targeting to formally prove delay bound. We would like to have the formal delay calculation for CQF as well, to just not give things shallowly related to the CQF delay analysis. And as well, what we want to address is to provide a buffer size calculation to guarantee zero congestion loss. And that's it.
Questions? So at the last meeting, we talked about that this would be aimed at being an informational document just to give context to help implementers figure out how they might build a DETNET implementation. And it would not be anything that was prescriptive. And with that sort of framing in mind, there was a lot of interest in the room in that. And so we thought it made sense to head towards adoption as an informational document to go through the working group. But we'd like to confirm that that's still the sense of the folks here. Of course, we'll do it on the list as well. But we'd like to get the sense of the room first in who thinks this is interesting work for us to be doing in this working group. So that's a reasonable number. How many people have read this document? It's about the same. I can't tell if it's more or less, but it's about the same. How many think that this is a reasonable starting point for a working group document on the topic? Maybe a little more than who've raised their hand before, which is perfectly okay, but always entertaining. How many think we should not adopt this document? No one. That's really good feedback. Thank you. Of course, we'll take it to the list.
Thank you.
Thank you. So now we're going to move on to Liang. You have a clicker here.
Good morning, everyone. I'm Liang from China Mobile. Today, I'm going to talk about, this is actually discussed in Canada, a little bit update on the requirements for bounded latency for DETNET. So this is really a informational draft. The reason I put it here to discuss this is in China Mobile, when we talk about evolve our network to support TSN or DETNET or PLC in industrial internet, we found that it's very important to understand how the layer 3 long-term or large-scale network to support a deterministic networking or to support bounded latency. So this is really a outline of what we understand the problem we're going to face if we bring DETNET with TSN to a large-scale network. So in DETNET now, as I understand, the data plane take TSN technology as the forwarding technology to basically enable the bounded latency. But when you put the TSN network, for example, we have the use case of connecting two isolated TSN island, then the actual connection between the TSN island will introduce some troublesome for maintaining the bounded latency. So we have.
Can I add a note? Just as we discussed before, DETNET specifies the technology that DETNET can work on its own within IETF technology, and TSN is a primary layer 2 subnet.
Yeah.
So it's not a must.
I understand. Yeah, and yeah, just to clarify, it's not a must, but it's one use case. I mean, so we have several schemes that proposed for bounded latency. We can find the draft. The first two are basic TSN, and then we have I believe it will be the next presentation, and then we have the segment routing one. These draft here is not to compare or analyze any of the scheme, but just to pose some factors that we think is very important to consider if we're going to adopt any data plane, pure layer 3 data plane solution, or the standalone DETNET implementation for large-scale network, the problem we're going to face. So first one is the use case of ditching TSN domains. TSN are synchronized. When you transmit data between TSN island, then the layer 3 will introduce the jitter on your latency, and that basically needs to be taken care of using a asynchronized network to bring the synchronized TSN together. That's number one. Number two is the propagation delay introduced by long link or long connectivity, because it will violate the T window that in TSN algorithms or TSN mechanism, that is a requirement. Basically, when you transmit a packet, if the propagation delay between two TSN nodes are larger than the T window on your cyclic scheduling, then you basically break the law. So that's something we need to face in a long link scenario when using DETNET as the forwarding plane. The last one is about the Perf Low Status. When it comes to large-scale implementation, you would expect the routers with the DETNET-aware routers to be an aggregated point where all the flows are aggregated there. So you expect to have a lot of status for the Perf Low Status. So if we think about different use cases, especially for VR, AR, or more advanced holographic ones, then you expect those connections to be really random. You will expect there are frequent activation and then tear down. So the status of the flow is going to be in a heavy load. If you calculate the if you based on the status to calculate the latency stuff, then it is really computing greedy stuff. So when we are facing these massive dynamic flows, then we probably need to consider a mechanism. This is not solution draft, but this is to pose the question. We need to consider how we are going to deal with these massive dynamic flows. So this is really a simple draft. It's not very long. And we feel that there are more requirements regarding large-scale deployment are going to come for different use cases. So we're going to have more offline discussion with the authors of those implementation drafts, not implementation, but the solution drafts. And we believe that maybe there's no one solution that can address all of these requirements, but the combination of those or different choice of those may accomplish these problems. Okay, that's all from me. Thank you very much.
So the observations you're bringing from the operational perspective are hugely important and valuable. And very appropriate to bring up in DETNet. The description, and as I read the document, you're really raising issues with TSN technologies, which are probably 100% valid, but we can't do anything about that here because that's a technology that's owned by the IEEE.
Yeah.
So bringing the issues to the IEEE and trying to work them there would be great. Here, all we can do is make sure that we have proper bounding on and constraints on what implementers do in using underlying technologies. So I think if we could restate this document translate this document into requirements for scalability of DETNet, that would be very appropriate and helpful. And move away from the issues with TSN. I mean, maybe use that as an example, but the fact that a particular TSN queuing technology doesn't work, for our standpoint, it means we just won't use it.
But we don't have a solution yet. I mean, that's I'm not here to bring any new work for TSN, but it's a question for us to consider.
I'm not sure we have to specify the queuing solutions in this working group. Right now, that's sort of out of our scope. So we talk about using different technologies. So we could have, let's say, operate over an MPLS point-to-point link where there's some local queuing algorithms that a vendor figures out how that meets the requirements of the DETNet service, and that would be fine.
Okay.
So as long as it meets the real operational requirements. So if you think there's some operational requirements from your networks experience or from your personal experience, that's really useful to capture and will be helpful to this group.
Yeah. Okay.
Saying it in the context of TSN just says, well, that doesn't help because it just means go to TSN. Yeah. So we have David in queue, and then just letting Norm is in queue after David.
David Black. Lou, I wonder if you're overstating the context of TSN. I can read the criticisms in this doc in two ways. One is TSN doesn't solve all the problems it could solve. IEEE could fix it. The other way to read it is TSN was designed to solve some problems. There are some interesting scenarios for DETNet that fall outside of TSN, and perhaps something ought to be done elsewhere outside of TSN to go address those. And I'd encourage consideration of both perspectives.
And what I was saying is that first perspective doesn't belong in this room.
I would agree. I would agree the first perspective doesn't belong in this room. However, I would also like to avoid implicitly excluding the second perspective.
And that's the other thing is this: the second perspective probably doesn't belong in this room, but it is perfectly reasonable to do in the IETF in other areas. For example, in your working group.
We can have a longer discussion about that now or in a couple of drafts. When do you want to have it?
Let's have it at the end of the solution document. At the end of the next document.
That's fine.
Norm, I have to push a button.
Liang, thank you for this draft. I agree and encourage you to present the requirements because that will be useful in trying to improve the situation. I think if you keep an eye on IEEE at the next meeting, you'll at the 802.1, you'll find that there'll be some presentations that will point out that the cyclic methods that 802.1 has are actually more powerful than most of the people in 802.1 realize, and that scalability in particular will improve. And I appreciate your comments on the requirements.
Thank you, and I'll keep an eye on IEEE progress as well. Thank you.
I wanted to come back to your synchronization slide just for clarification. Can you go back to the slide? So in DetNet, we don't dive into synchronization details, but say in the architecture, for instance, that, and this is along the principles that we don't want to reinvent the wheel, that the idea is to use existing time synchronization or frequency synchronization techniques as needed in certain deployments. So, for example, in this case, it could be that the DetNet domain interconnecting two TSN domains implements a time synchronization technique, and the TSN domains implement their technique, or it could be the same, and the DetNet routers could be time-aware relays. So it's not impossible to have time sync overall end-to-end. We just don't dive into those details here.
Yes, just one comment. If it is a long link or large-scale implementation, like what we are doing in TD, LT network, backhaul network, the synchronization, yes, it's doable, but it brings you a lot of work as well. It is, yeah, I agree with you, but it is really bad because we know there's a solution for unsynchronized with bounded latency. So that's basically why we triggered this here. Yeah. Okay.
Thank you. Christina?
Good morning, everyone. I'm Christina from Huawei. I'm going to present the large-scale deterministic network graph. Let's look at the requirement for this work. We have a requirement from DetNet. Both the DetNet charter and architecture says DetNet need to provide bounds on delay variance. We also noticed that the unsynchronized traffic shaping works well in providing the upbound on delay. However, there is no guarantee on lower bound delay. That means the jitter is equal to the propagation delay variations. Another requirement is DetNet should work over a fast transit link speed network, like the common outside building and campus network. Normally, the link speed will be more than 100 gigabit per second. So the DetNet needs a per link queues option that is available at that speed. We also have other requirements include the easy calculate delay or jitter. And the jitter of mechanism not subject to link jitter, but per link cycle mapping. The goals of this work is to be an information DetNet working group document and introduce requirements and framework, which is independent of specific forwarding plan solutions, generic applicable to DetNet scenario. Use as justification and reference for normative work in other working group. We will figure it out later, but for example, the queues model in TSVWG or DetNet, and the forwarding plan encoding like the IPv4 for IPv6 DSCP or UDP extension in TSVWG, or the IPv6 extension header in 6man, and SR encoding in Spring, MPLS specific encoding in MPLS working group. This is a classic scenario in DETNET. We use a DETNET domain to connect the two TSN islands together. At the P node, DETNET should provide the queuing management like shaping or scheduling to provide the congestion control. So our work is a simple, scalable queuing solution in the scenario. We noticed that there is a kind of solution called cyclic forwarding have proved work well in TSN that can provide bounded latency and jitter. It's a kind of synchronized forwarding scheme without per flow queuing state on every hop. Synchronous packet forward across all hops within a single synchronized seeker. But this kind of mechanism have some challenges. The first one is the nanosecond time synchronization requirement among all of nodes. The second one is limited physical size due to the cycle time. The larger the network, the smaller the percentage of traffic can be synchronized due to the long link propagation delay. In order to overcome this challenge, we propose the large-scale network cyclic forwarding. The basic idea is carry cycle identifier in packet. This is a kind of non-synchronized forwarding, buffer cycle and send after all packet for cycle arrived. So what we can achieve is we still keep the key benefit of traditional cyclic forwarding. It's easy to calculate the end-to-end delay and jitter, have time bound on delay and jitter. But we limited the physical scale limitation can support arbitrary link propagation delay. We also limit for the time synchronization. We only require frequency synchronization in order to control drift between two adjacency node cycle time. And we think the frequency synchronization is much easier than the high occurrence time synchronization. We have made some change to the draft since the last IETF meeting. The first one is we add a new figure to illustrate that the common IP and Mpls forwarding priority queue couldn't guarantee the bounded latency and jitter due to microburst and microburst iteration. If we have no control on packet behavior, then the worst case will be packet arrive at the single point simultaneously. Then the packet wait in the queue and produce microburst. Microburst iteration after several hops, then there's no way to guarantee bounded latency and jitter anymore. We also refine the potential way to carry minimum 2-bit cycle identifier. Firstly, we remove the ACE type of ACE NAT header from the list, and we also add some new approach such as the UDP option, the seed of SRv6, the flag field of SRH, the 2-bit in IPv6 destination address, and so on. We also add some description for two models that implement the proposed cyclic forwarding method. They are swap model and stack model. In swap model, a packet carry cycle identifier, and at each hop, the cycle identifier will be swapped to a new one according to the cycle mapping table. In stack model, a packet will carry a stack of cycle identifiers, one for each hop, like the SRv6 does. Each hop map based on the next cycle identifier. Okay, in summary, we want to make sure the requirement and solution are well understood through draft and verify that DETNET working group agrees on requirement being valuable. And we want to ask for working group adoption before next IETF meeting. We will do another version resulting from the feedback we received. And we think this is not the only queues model useful for DETNET, but this model is very important because it's the least complex per hop queues model. That's all. Thank you.
So I'm a little unclear on the document when reading it. I see that it's informational, And then it goes into a lot of queuing details and saying that there's issues with TSN. Are you looking to provide comments on the TSN queuing mechanism? Are you looking to define a new queuing mechanism? Where are you going with the document?
This document just provide a basic, a generic framework to deploy the queues mechanism on layer 3 network, and the specific encapsulation as a reference to do the specific encapsulation in other working group.
To do the encapsulation?
Yes, we need to carry 2 bits cycle identifier to support the queues grantee. So we need.
Where's that queuing mechanism defined?
The queues mechanism is the internal implementation inside a network. It's not the important thing. Why we explained the queuing mechanism is because we need to give a reason why we need the 2-bit cycle identifier.
Yeah, I think that gets into that definition of the queuing. And right now, defining queuing mechanisms in the IETF really happens in the transport area.
Right.
So I think if you want to come back, okay, if you want to define support for a queuing mechanism, I think it has to be a standard queuing mechanism. And so I think we have to run this through the TSV area first and have them give us the answer for the queuing mechanism, and then if there are requirements for signaling.
Okay, so what we tell is accurate as a co-author. What we try to describe in the document in the slides is the scheme on how to break the deadlock between, what working group is doing what in response to which other working groups, right? So we wouldn't want to define a queuing mechanism. I think what we would want to define in TSVWG is the pro-hop behavior, which is the externally visible result of the queuing behavior. So because we kind of typically have the approach in the IETF to try to avoid defining internal behavior. So that's also been said in the slide in the deck, the PHB in TSVWG. But, our best understanding was that TSVWG, to basically accept such work, it needs some other working group to show the interest in this, and which is exactly what this document is meant to express by being an informational DETNET working group document, right? It's basically a document expressing the interest of DETNET in, having other working groups creating standardized aspects of that solution.
Yeah, I agree with what Tuolas is saying, that this document sets up the problem and gives the context of DETNET. Then we need to get some work from the transport area to validate the per hop behavior. And then we need to go to other groups in order to specify the marking in the package itself. So there's 3 pieces of work. Well, we've got to start somewhere, and this seems to be the best place to start.
I completely understand how the previous document sets up the requirement. So I really understand how the previous document sets up a requirement. I don't understand how going to this level of detail is setting up the requirement. It seems to be setting up a solution. And it's not, I think the right place to define the solution for the queuing mechanism to meet the requirement is in TSV working group. This seems to be setting, it seems like a nice intro to a solution proposal that you could be bringing into the place to standardize that queuing mechanism.
Okay, David Black, wearing entirely too many hats. Transport Area Advisor, DETNET Working Group, TSVWG Working Group Chair, and one of the original architects of DiffServe, which we seem to be talking about here. Christina, could you go back to the slide on microbursts? Because I think I think what we have on this slide, you'll notice there isn't the word queue anywhere in this slide. Nonetheless, what I see here is a behavioral spec that could probably be the foundation for a PHB that basically starts from, I see the word queue somewhere, but where this basically starts from is that we have a time sequenced stream, and we want to ensure that it doesn't pile up and turn into uneven microbursts. I believe that can be done by referencing some sort of notion of time interval without the nuts and bolts of exactly how the queues work inside. And that kind of careful teasing apart of things can get us to a PHP spec that doesn't tell the people doing silicon how to build the queues.
I think what you're saying makes a lot of sense, although I would call it an in-serve flow spec, not a PHP, because this is on a per flow basis. It's not on a per class basis.
We have to have a longer discussion about that one, because I think I've heard from the authors in other places that they're more interested in the diff-serve framework. Nonetheless, I understand the in-serve comment. The crucial point I wanted to make is that I believe that this chart provides the basis for the on-the-wire observable behavioral spec that gets you away from explaining exactly how the queues work in the silicon.
That would be fine, and then we would remove all the queuing behavior discussion from this document, and then we could have something that would be useful here. When we start getting into the queuing behaviors, I think that's the place where we've passed what we should be talking about at DETNet.
Mumble. You can certainly put the queuing behavior in as an example to prove that this isn't idle hand waving of something that's unimplementable. You just have to make sure that it goes in with the words example in all the right places.
Yeah, I didn't see that when we did in-serve or diff-serve, and so it makes me really uncomfortable.
Understood. This one's a little novel. It doesn't hurt in my mind to have the details of how you could make it work. But no, point noted.
An appendix might be a compromise position.
Yeah. Yes. So maybe 2 points. So first point, if we still haven't gotten the point over, we still need to improve the text or the slides, right? So when you're saying in-serve and it's per flow, it's exactly the point of not having per flow state in the midpoint P nodes, right? So only state really for the class that is basically not having to scale up with more and more flows, right?
That's what we've called, as we've heard in the flow information, that's, or maybe it was Janosch, that's an aggregate flow. So the fact that you have one what looks like in the large scale network is one flow, and it's supporting 1,000 or 1,000,000 other flows, that's an aggregate in our architecture.
No, because you never have a situation that basically more user traffic creates more of these flows. Even in aggregated flows, you will always have, the notion of a flow is something that has a relationship to, basically application levels.
So I think that's the place to focus, is the discussion of how you are proposing to change our architecture, that to have a solution that is not an aggregate flow to deal with scaling. Right now, all we have in our architecture for handling scaling is aggregation of flows.
Yes, understood.
That's
yes,
it.
Exactly.
So if you want to move away from that, and that's really the point of this draft, that should be the focus of the draft. Throw out all the queuing pieces, talk about the architectural implications, and then we can talk about how to implement it. The queuing pieces are really down in the guts and outside the scope here, but the point that you've just made, if that's really the main focus, or I thought I heard you say is the main focus. I could be wrong, but I thought I heard you say the main focus is to get away from the aggregate model. That's very new, and that's cool. That's great to bring that in, but let's make that the focus of the discussion.
Yeah. By the way, the whole IETF mindset of trying to completely eliminate discussing anything internal to the router, can I invite you to 3 p.m. on the router architecture discussion, where basically that's exactly a big bitching point. I don't know if, for example, any of the TSN specifications would have been able to be implemented correctly if, if IEEE would have taken the same stance.
Well,
but
we're not
it's
the
fine.
we're not the IEEE.
No, understood. But I'm just saying that.
We don't want to step on their toes.
Yeah. No, we're not stepping on their toes. The only thing that we're saying is that we're fine with kind of any structural stuff in documents in terms of making an appendix or something like that, but without having any idea of how somebody else could have implemented it, right, it's very hard to bring a lot of the QoS technology. I think even the people who wrote the PHP always had basically in the back of their mind, and in as much documentation as they could find examples, right? So, and I think
Sure.
that's...
I mean, I was
that's all
in,
it
in
is.
the days of InServe, I was there building solutions and queuing mechanisms, but the IETF chose not to go down the path of standardizing them. I certainly agree with you. The implementers always have an idea of how you're going to implement it. It's just a matter of what we standardize and where and in what forum. But the notion of doing a different form of aggregation is an important idea, and it sounds to me that that's where we should be talking in this document.
Okay, this is Esama Matpuri from EPFL. Can I have the slide for the delay calculation? It is 2 times the parameter t, right?
Yes, right.
So I just wonder that this parameter t is the same at every node.
The same length t.
They are the same at every node, right?
Yeah.
So I'm just wondering, isn't it hard to have a lot of nodes inside this .NET network that have the same T? Maybe one node requires to have a bigger T because of a lot of ingress ports or the flows entering this node.
Yes. The sameness T is actually already easier to be achieved compared with the high occurrence time synchronization required by other TSN technologies.
Yes, right. So in TSN, it makes sense because you don't have a lot of nodes and you can make them synchronized on the same T. But if you have large scale network, I find it hard to have the same T. Mm-hmm. And if it is not the same T, then there is another issue. How can you guarantee that from one ingress port, there is just one packet from one cycle? Maybe there is more. Maybe not just 2, because I notice in your document that you assume that maximum 2 packets are coming from the previous node, while if the parameter T is different, then for sure it's more than that, right?
Yeah.
And so how is it going to be addressed in the large scale .NET?
Yes. I think a synchronized shaping can help to solve this kind of problem, but the ATS has another challenge is it couldn't provide the bounded jitter.
Yes, sure.
Yeah.
I'm not talking about ATS. I'm talking about this approach of LDN, right? Maybe there are some challenges in ATS, but what I'm concerning is the delay calculation provided in this document is not accurate. I mean, there might be some challenges that I would prefer to have the results first in some papers and can be proven somehow and the results reported in the draft, rather to have the mathematical proof inside the draft. Maybe it's more interesting to have the results.
Okay. So I think this is a great conversation to have offline, and also, great conversation to have offline given the time constraints. I do think it'd be good to spend a few more minutes with Stuart and David, see if we can get to some resolution of where we go next. I will point out that we're over time on this slot, which means we're eating into the next slots. But given that we've talked about this a few times, it seems like it's the right use of the meeting time. So if you could take that topic, the details offline, and that would be great. Thank you.
Okay, thank you.
So three things. First off, I don't think, are you listening, Lou? First off, I think it's grossly misleading to suggest that we're treading on the IEEE toes, as you suggested earlier. This is not the intent here. The intent here is to solve this entirely at the packet layer, which is not the way that, so we don't get anywhere near what they're doing. We want an independent solution. Secondly, the scope and range of we're trying to address is larger than IEEE are addressing. Thirdly, I think that one of the things that's missing here is that we probably need to put a catalog document together that describes the set of queuing mechanism, or the set of whatever you want to call this class of mechanisms, so that people know which one to pick, what its advantages and disadvantages are for different applications. But finally, I think that this is a perfectly valid piece of work in its own right, and we do need to find a home for it.
Yeah, and good new queuing behaviors certainly are in the scope of the IETF, and I think a fine thing for us to be working on, particularly if they support DETNet. I'm just saying that that part doesn't belong in this group. We want to use what's done in the other parts of the IETF. I'm not saying don't do it in the IETF.
Well, we need to do things in other parts of the IETF, right? You know,
Yep.
And so you know, an approach here is to incubate the document here and then figure out with the ADs where it should go,
Yeah.
rather than the other way around.
So the thing that I've taken away from this is that the main point of the document is to introduce a new form of scaling mechanism into our architecture. And I would really like us to focus on that and nail that out. And if that means a separate document, that's fine too. So you can have a mechanism document and then one that covers this architectural implications. Because that architectural implication is a huge one. It's come up a few times before. And it's important to capture that and decide as a group if that is something we want to include as a part of a DETNet solution or exclude. Right now, to be clear, it's excluded. If you want to include it, we need to bring that in and agree to that. Right now, the only way we have for scaling is the aggregate flows. And I thought I heard, again, I might have misunderstood. So, you know, I'm happy to be corrected, either in session or out of session. But if that really is the case, where it's something different than what we have defined for aggregate flows, that's really important.
I believe it is. I believe that that's the intent, and that's a necessity to get to the next level of scaling.
So we really should make sure to have to focus on that part in the discussions and bring that in, and then we can gauge consensus on it. We're jumping way down into queuing mechanisms without even agreeing that this is something we want to work on. That's an important piece.
Okay, Lou, I think you hit the nail on the head in that very last comment, which is now wearing a TSVWG hat. TSVWG is quite happy to do work for other working groups we've done so many times. I remember the amazing adventure I went through to get us off the critical path of WebRTC so we wouldn't be responsible for cluster 238. So, I mean, we have lots of track record doing this. However, there needs to be a cooperative relationship with the worker who is going to use the work, and hence the decision needs to be made here that this work is interesting and high-level scope and requirements. Yeah, we can work out details of exactly what the forwarding behavior through the node needs to be to solve the problem, but the problem's got to be defined here.
Right, and I think the previous document seemed to be defining the problem. This document seems to be more about the solution, but with the addition of this new concept of handling scaling without using aggregation, flow aggregation. And again, I think I've made it clear that to me that's something that we don't have. And I say to me so because I want to give an opportunity for other people to stand up and say I'm wrong and that we really do have it.
So in what you've been saying, I hadn't heard the word requirements. So because last time around at 103 when we're discussing, the feedback was more we need to describe the requirements. So is it fair to say that the document itself should also relate to, you know, how as we try to do in the first slide, right? So how we think there are requirements to solve this problem.
If you focus on requirements, it seems that you're doing the same thing as the previous document. I think we should have requirements in one place.
Sorry?
The previous document's about requirements. The previous document's title is requirements for large scale.
Right. Okay, but would it be fair to say that from what I heard from David is that we definitely want to have a requirements document? However, we split it up, whether we merge into one document or two documents.
Requirements are useful. I think I said that,
okay.
And if I didn't, I should.
Gotcha.
Yeah, requirements are definitely useful. We have Norm in queue.
Yeah, minor point. The bounded latency draft does point out that some specific queuing mechanisms, among them at least one of the IEEE mechanisms, does not require any state in any node along the way, and so does allow dynamic rapid additions and deletions of traffic. So I don't think it's a wholly new thing to say we have to desire scaling that's not related to flow aggregation. It's not clear that's a completely new concept. I'm not arguing for or against anything in the draft, just pointing that out.
David Black again. I think I see two notions of scaling that ought to be carefully distinguished. One is scaling in terms of flows, however aggregated, and the other, which came up much more strongly in the previous draft, is scaling in terms of network scope.
I think we have quite a bit of aggregation semantics. So until we have a good articulation of what the new mechanism is and what the failings in the current ones are, I think it's a little hard to figure out where the gaps are.
Right, and when I looked at this stuff before the meeting, my sense was that to the extent there was a functional gap somewhere that this working group ought to be looking at, it was in network scope. Things like the can you extend the time synchronization to arbitrarily large networks? Going back to the earlier comments about administrative domain, are you going to get uniform time synchronization across multiple administrative domains? What happens at high jitter links, that kind of thing.
Yeah, and those are places where we definitely want to have solutions, so we can translate those requirements down to the TSVE working group and have that group work on solutions. So we have run out of time, which means we are skipping. Just bring up the agenda. We're skipping 2 slots that were individual documents, 00 individual documents. We do encourage you to take a look at them. One of them was on SR, and we did want to talk about that and in particular mention that we chairs need to work with our AD and see, talk to the SR and also the SR chairs, the spring chairs, to see where that work might make most sense. Or that discussion should take place. So with that, we are out of time. We thank you all for contributing and participating, and we definitely apologize to those last 2 presenters and encourage you to go look at that material and discuss on the list. And if someone wouldn't mind handing up leaf sheets, that would be awesome. And we will see you in Montreal. Thank you so much. Thank you.